Question 7. So question is that z of t is equal to n1t times cosine of omega t plus theta plus n2t times sine of omega t plus theta, where theta is that between that is u that between 0 and 2 pi. So he's asking try to find the expected value of z of t. So as we know that n1t and n2t is a wide sense stationary process, so that means that the expected value of n1t is equal to eta 1t is going to equal to eta. E of the n2t is going to equal to eta 2t is going to equal to eta 2, which are constant. So the expected value of z of t is going to equal to expected value of n1t cosine omega t plus theta plus n2t sine omega t plus theta. So which is going to be equal to e of n1t cosine omega t plus theta plus e of the n2t times sine of omega t plus theta, and it's going to be equal to e of n1t times e of the cosine omega t plus theta plus the e of n2t times the e of the sine of omega t plus theta, and then it's going to be equal to eta 1 times the 1 over pi integral from 0 to 2 pi cosine omega t plus theta d theta plus eta 2 times 1 over pi integral from 0 to 2 pi sine of omega t plus theta d theta. So it's going to be equal to n1 eta 1 times 0 plus eta 2 times 0, which is going to equal to 0. So it doesn't really matter n1t and n2t have 0 means that the z of t has 0 means because the integral of cosine sine r is in it over its period is going to be equal to 0. B, trying to find the r z of t1 t2. So asking is the z of t wide sense stationary process. So r z of t1 t2 is going to be equal to expected value of z t1 z times z t2 is going to be equal to we just plug in the numbers. Here is going to be equal to n1 t1 cosine omega t plus theta plus n2 t1 times sine of omega t plus theta times n1 t cosine omega t plus theta plus n2 t2 sine of omega t plus theta, and then these two are times together, so it's going to be equal to expected value of n1 t1 cosine omega t plus theta times n1 t2 cosine omega t plus theta plus the expected value of n1 t1 cosine omega t plus theta times n2 t2 sine omega t plus theta plus the expected value of n2 t1 sine omega t plus theta times n1 t2 cosine omega t plus theta plus the e of n2 t1 times sine of omega t plus theta times the n2 t2 times sine of omega t plus theta. So this is going to be equal to, so it's going to be equal to Rn1 tau times the expected value of cosine omega t plus theta times cosine of omega t plus theta plus the eta 1, eta 2 times the expected value of cosine omega t plus theta times sine of omega t2 plus theta plus the eta 1, eta 2 times the expected value of sine of omega t plus theta times the cosine of omega t plus theta plus the r eta 2 of tau times the expected value of sine omega t plus theta times the sine of omega t plus theta. So this we simplify it. It's gonna give us the solution of 1/2 times the Rn1 of tau plus Rn2 of tau times the cosine of omega tau is going to be equal to Rz of tau. So z of t is a wide sense stationary process. Say find the Rz of 0 if z of t is the wide sense stationary. So we're just plugging the number into the equation on the question B. So Rz of 0 is going to be equal to 1/2 times Rn1 of 0 plus Rn2 of 0. So it's going to be equal to 1/2 times the expected value of n1 t squared plus the expected value of n2 t squared.